Hello, my name is Sandeep Singh, and today I'll be presenting the stall protection system in the Challenger 605. So, here's an introduction. So, the stall protection system is an integral part of the flight control system and is used for detecting and suppressing the effects of a possible stall. It uses tactical, visual, and audio alert systems to warn the airplane pilots about any stall conditions. So the stall protection system is run by a computer which monitors the following inputs. So there's a stick shaker which simulates aerodynamic buffet, automatic activation of the engine igniters, which is called auto ignition, so this reduces the chance of stall. The automatic autopilot disconnect, an oral warning in the form of a warble tone, 2 red stall lights on the glare shield, and a stick pusher which applies a full nose down elevator input to reduce a dangerously high angle of attack. This is helpful for preventing a deep stall condition. So the SPS system uses many sensors. One of them is called the angle of attack sensors. So the SPS continuously calculates the angle of attack trip points using the input information. An angle of attack trip point is basically if the angle of attack increase is higher than a certain level dictated by the system, it will send signals to the SPS alerting it of any impending stall warning stall conditions. So as this trip point is approached, first thing that happens is continuous ignition is activated to reduce the risk of a stall, like I said. If that angle of attack continues to increase, then in the cockpit there is a tactile indication in the cockpit via the stick shaker, and the autopilot also disengages. So stick shaker essentially is an alert for the pilot and the co-pilot, warning them that they are entering stall conditions. And after the autopilot disengages, if the angle of attack still continues to increase, the stick pusher activates, along with the red stall annunciation displayed left of the attitude director indicator, and the master warning lights on the glare shield, as well as a warbler oral warning. So the stick pusher is essentially it moves the controls of the airplane forward with a force of about 80 pounds, pitches the nose down of the airplane to so that it's able to escape that stall condition. The stick pusher only activates when the signals from both channels of the SPS system or computer are in agreement. If the angle of attack starts increasing at a rate greater than 1 degree per second, the SPS computer sends the tactile, oral, and visual signals to the cockpit at a much lower AOA so that the pilots are ready in advance and that they can perform the maneuvers needed to escape the stall conditions. So the stall protection system has several different components. Here are a few of them. There's the ICAS displays. There's the dual channel SPS computer, the angle of attack vanes, the SPS test indicators, stall lights, stick shaker and an audible warbler, a stick pusher subsystem, a flap position, the G switch, lateral accelerometers, digital air data computer signals, and 2 SPS control panels inside the cockpit for the pilots to use. So we'll be going through all of these systems just briefly. So for the stall protection computer, it has two channels. They are independently powered and can be used with the DC bus, the direct current bus, and the battery bus. This computer also monitors the angle of attack rate and the rate at which the system increases, or which the angle of attack increases. If the angle of attack increases too fast, it automatically triggers an alert in the cockpit. The computer's output channels are used to activate and or suppress the stick shaker and or auto ignition. The computer's trip points are also used to warn the user, the pilot, about the presence of a stick pusher. For the angle of attack vanes, they are mounted on either side of the fuselage. They are equipped with a trailing vane unit and a potentiometer, and the angle of attack is measured using an external electrical signal. For the stall protection system test indicators, they displayed the compensated angle of attack signal for the channel, and it is used for monitoring and testing. The stall fail message is displayed on the main page of the ICAS when there is a failure in the stick pusher or in the stick shaker circuits of the SPS system. This issue can also be caused by the sudden loss of power to one or more channels of the SPS computer. The stall lights in the cockpit, there's a red stall light located on the side of the glare shield that faces the road or the runway. The light is controlled by a push signal from either of the two SPS signals or channels. When the audible stall warbler is enabled, the push signal will also be used. For the stick shakers, it is mounted on the control column and is powered by the computer channel. It produces a mechanical shaking action when the column is moved. The operating range or speed of the stick shaker is it idles at 50% and its max range is 100%. The stick pusher subsystem, this is an integral component of the SPS. It can only be activated when it receives a push signal from the two SPS computer channels. The flap position switches, for this, a flap position transmitter is mounted on the inner flap assemblies. When the transmitters pass to the right and left positions, they send discrete signals to the SPS computer. The computer uses the signals to lower the AOA trip points for the stick pusher and the stick shaker. The angle of attack trip points for each channel are equal to the lower angle of attack that occurs when a stall occurs. For the G switch, it's located on the pressure bulkhead of the upper avionics bay. It serves as a cutout for the stick pusher when subjected to less than 0.5 Gs of force. The lateral accelerometer. So there's two lateral accelerometers that are used to provide a reference signal for compensation of an AOA vane angle. These devices are designed to be used with stall protection computer channels. Then there's the digital air data computer signals. There's two computers located in the cabin's avionics bay which monitor the altitude and provide a signal to the stall warning computer. When the digital air data computer signal indicates an increase in altitude, the computer gradually lowers the angle of attack trip points. The ICAS alt comp fail message will appear on the display of the aircraft's instrument panel when the system has experienced a loss of altitude compensation. The message will also show the failure of the SPS computer's altitude compensation circuits. Then we have the control panels, which is there are two control panels and they have two detent switches labeled stall, prod pusher, and SPS test. These control panels are specifically for the use of the SPS system in the airplane. So how the SPS operates. So the signals of the AOA sensors are transmitted to the right and left channels of the SPS computer. Each channel computes an angle of attack trip level for each angle. These trip levels are adjusted for various factors such as flap angle, pressure, altitude, and stick pusher activation. If the angle of attack is allowed to increase steadily, the stall warning sequence occurs as follows. When the angle of attack hits the auto ignition trip sensor or trip threshold, the SPS computer senses the presence of an ignition relay in the engine. This is then turned on by the green LED lights on the start/ignition panel. When an attack angle hits the stick shaker trip level, the SPS computer sends a DC output to the assembly. When an SPS computer channel activates a stick shaker signal, the autopilot is engaged. The go-around relay is then initiated to initiate the disengagement of the autopilot. The speed of the stick shaker motor increases from 50% to 100% if the angle of attack rises by 3 degrees. When the SPS computer channels detect an angle of attack at the pusher trip level, the stall warning lights will flash and the stall protection oral warning will sound in the cockpit. The stick pusher system's logic circuits are responsible for controlling the servo actuator which drives the capstan. When the elevator reaches the pusher trip level, the capstan rotates and turns the control columns forward, which is why it's called the stick pusher, pushes the stick forward. To continue, the following conditions, these terminate the stick pusher operation. So the compensated angle of attack signal decreases by approximately 5 degrees from the pusher trip threshold. The G switch activates at 0.5 Gs. The pilot/co-pilot's autopilot/stick pusher disconnect button is pushed. The stick pusher can only operate when both channels of the stall protection computer sense the pusher trip's threshold. So for the interior cockpit, there's various ways to monitor the system, the SPS system. So one is the ICAS display, as you can see here. There you can see the multi-function display, as well as the service message history. So this shows you all the faults or the messages the computers has to relay to the pilots. And then we have the CAS. So the messages in the CAS is very straightforward. You have the stall fail, alt comp fail, and you have advisory signals such as the ignition A/B. For the first table, G1 is for the CL604, which doesn't really apply to us because we're talking about the 605, which is table G2. So for the stall fail, if the stall fail message caution comes up on the CAS, it indicates that one or both channels of the stall protection system have failed, resulting in the stick pusher system inoperative. And as we talked about earlier, the alt comp fail, this indicates that an attitude director control altitude split of greater than 2000 plus or minus 250 feet, or a failure of either left or right attitude compensation circuitry. There's also an advisory message, it's called the ignition A/B. This comes on automatically when the aircraft stall is detected or when a stall test is initiated. So finally, system testing. You can be tested in weight on wheels conditions only, or it can be tested via the test switches on the test panel. So this it just shows you how to test the system, and there's indicator needles inside the cabin as well as the different test switches. And yeah, so that's the end of the presentation. Thank you for listening.